Let's check out this weird example where we're giving 5 beautiful graphs and we need to guess which equation corresponds to each graph. For now, we don't know lots of stuff about the parametric equations and polar equations, so we are offered to think about the range of x and y in each case, and also periodicity and symmetry of each picture. So I would say the easiest one would be to do this one, B. This is the only one, the only graph that shrinks to 0 when time passes. So again, as you can see, we have 3 variables all the time, x, y, and the parameter t. That's the whole kind of idea of parametrization, that the third parameter shows up. So you can imagine the third parameter is t. It's time. It's not on the graph anywhere here. All the graphs have x and y Cartesian coordinates. So t is supposed to be like a third dimension, which you keep in your mind. So when time t passes, that means at t goes to infinity. As you can see, this graph of the function shrinks to 0, right? Both height is y, goes to 0, and x goes to 0, as you can see, right? I would say as t goes to infinity, x and y both shrink to 0. There's only one function in the list that has this property, the one that has division by t. So let's see, as t goes to infinity, you have 1 over infinity case for x and y, and that is why since cosine and sine are restricted from -1 to 1 anyways, those are just numbers, those are not infinities, 1 over infinity and 1 over infinity will give you 0 for x and y. And that's why this is the first one I would do, and I would say that this is B. Nice. Then I would notice difference between all other pictures. What something in common you see? And there are interesting things I see in common, which are these two guys, C and A, are restricted, as you can see. They are keep wiggling around some kind of area forever. So they keep going forever, but they don't go to infinity minus infinity, as you can see. Same this one, no matter how much it's gonna wiggle, it's not gonna go to minus infinity to infinity. The last two, however, do go to plus infinity minus infinity. That gives me thinking that there should be two equations here who at t goes to infinity, again, as t goes to infinity, something happens with x and y. Some or both will go to infinity as well. So let's figure out what's the difference between those two cases. For d, as t goes to infinity, time goes to infinity. Then x is the one that goes to the right, yeah? At plus infinity, let me make it very clear that we need to check actually both. So as t goes to plus infinity, then x for d goes to the right forever, makes sense? Then x goes to plus infinity forever. What happens with height? Y. Y goes to plus infinity as well, plus infinity, because the spirals keep going diagonally right and up forever. So that means both x and y goes to infinity. What happens at t goes to minus infinity? So the other way around. Let's see. On the left, though, I will change the color. Now x goes to minus infinity, as you can see, and y go to minus infinity as well. So x goes to minus infinity and y goes to minus infinity on the left, so at minus infinity. Make sense? So very, very interesting. That seems like it's basically a line, but the one that wiggles. And by the line, I mean, isn't it just y equals x? But with a wiggly part, kind of. So it looks like, I mean, you have to admit, it looks like y equals x, but just the one that wiggles a lot, has loops. So what kind of equation has the property? First of all, we agreed that only two actually go to infinity at some kind of point. So let's see what kind of those two. C is periodic, because cosine and sine are periodic. So they will stack from -1 to 1 or something like that. Then also let's see which one is. This guy, the first one, A, is periodic as well because it only has cosine and cosine, sine and sine, so it also stuck between some kind of numbers, maybe -1 to 1, maybe something else. So those two are periodic, and this one is periodic. So the other two left in purple, these guys, are not periodic. And do you see why? Because it has t in it. This t and this t and t squared makes x and y blow up to some kind of infinity. So now we just need to choose what kind of infinity it does. The first one blows up to plus infinity and plus infinity at t goes to infinity, and then minus infinity and minus infinity at t goes to minus infinity. So that's how I know it's D. Make sense? Also, remember that sine and cosine are restricted between -1 and 1 or whatever number it is. So they don't make big change, but t blows up. Also, I just mentioned this phrase, doesn't it look like x equals y anyways? So if I imagine that these cosines and sines do not exist, I will have x equals y. I will have x equals t, and then y equals t. So that basically means x or y equals x, right? And y equals x is a line. What kind of line? This kind of line, which goes through first and third quadrant, right? So it is indeed a line which has wiggly parts that shows up from sine and cosine. Because sines and cosine are oscillators, they basically make this line to be loopy, so it goes in loops. So that makes sense. That's how you know that it is indeed D. But the other one is E, because at plus infinity, let's check why. At plus infinity, x goes to plus infinity, but at minus infinity, x goes to minus infinity, just like before. Indeed, at plus infinity, x goes to the right forever, and at minus infinity, x goes to the left forever. Cosine doesn't really change anything, it's restricted. But y has sine, it doesn't do anything because it's just sine, but t squared will make it both plus infinity and plus infinity, when t goes to plus infinity and minus infinity. So t squared makes y an odd function, basically a parabola, right? So I can claim that the second graph looks like y equals x squared. So that's what happening here. Y equals x squared. Because y goes to plus infinity when t goes to plus infinity, and y goes to plus infinity when t goes to plus infinity. So that's how I know that this is E. Again, you can see the same idea I had before. If I imagine that this sine and this cosine is not there, what I'm going to have, I will have x equals t, y equals t squared, which means if I plug t equals x, it will be y equals x squared, and that is parabola, right? So let me write down. This one was a line, this one is parabola, and it's exactly what it is. It is parabola. And then these cosines and sines, then they add the wiggly part for the parabola. So it basically oscillates. And now there are only two left. So these are the hardest ones, I would say. Oh, let me finish writing for this one. What was different here? At plus infinity, x goes to plus infinity over here, and x and y goes to plus infinity up. So at plus infinity, we go to the right and up forever. But in minus infinity, the second graph, x goes to minus infinity to the left, as you can see, to the left. But y still goes to plus infinity, and that's how we identified the second graph, that it was E. The other two in green are the hardest ones. We only know that they are restricted. They don't get crazy, as you can see. They're restricted. So they're periodic. By not getting crazy, I mean they're periodic. They keep repeating forever. So when t goes to infinity, they keep repeating, as you can see here. T goes to infinity, it's still going to be repeating and repeating and repeating. The difference is, well, first of all, this guy looks simpler, so let's start with this one. Cosine and sine are both between -1 and 1, and that will give me the answer. Seems like this is the guy. If you zoom it in, it is from -1 and 1 on both sides, height and width. So x seems like is running, so x is my left and right. X is not going beyond -1 and 1. And height, y, is not going beyond -1 and 1. So that's exactly how we know that this is C. Because x is cosine and y is sine, it doesn't matter 5t not 3t, that just means how stretched or shrink the wiggle part is going to be, the loopy part. But the height and the length are restricted between -1 and 1 because, as you remember, should I write it down for you or not? Do you guys remember? Cosine theta is from -1 and 1. And sine theta is from -1 and 1. We know that from school. So that's important to remember. If you don't remember, there's a graph. For cosine, it's like this. For sine, it's like this. So both have walls, -1 and 1. Basically, cosine and sine are wiggling forever in the tunnel from -1 to 1. And the last one seems like have different domain in the range, and that's what we need to calculate. For the last one, let's figure out. I have a special space over here for you. So number 1 is the hardest one, I would say. If we know that cosine and sine are going from -1 to 1, then x will be from, let's calculate. X will be from, what is the biggest cosine can be? 1. Then it's going to be 6 plus 1. Oh, let's do more precise. 6 times cosine, the biggest cosine can be 1, so times 1, plus 1. So that means x is between, definitely the highest point of x is 7. What is the smallest cosine can be? -1. So that's going to be 6 times -1 plus -1. That's -6 minus 1. That's -7. So x, that means left and right part, right? Goes from -7 to 7. And indeed, if you zoom in, this one is from -7 to 7, so it matches. The x's keep running from -7 to 7. Let's check y. So x came from this equation. Y is coming from this equation. What is the biggest y we can have? Sine can be 1 for this guy. So it's going to be 6 times 1. But this sign is negative, so to maximize the total, I should minimize this second sign. What is the minimum for the second sign? -1. So I'll have -1. Does this make sense? If I want to find where the biggest y can be, I want to maximize this sign, so that's +1, but minimize the negative sign, that's -1. So y is as well going to be less than 7. 6 minus -1 is 7. Same, but now with the minimum. This should be minimized, so 6 times -1, that's the minimum sign we can figure out. And this negative sign should be maximized if we want to have the minimum total. So that's going to be -+1. Well, -6 and -1 is -7. So that's the domain for y. Basically, that's range, right? What is my range? And indeed, the height is keep running from -7 and 7. If you would zoom in, you will see that I checked. I did zoom in before making this video. And that's how you know all of them. See, I did not just guess the last one based on the leftover, since it was the last one left. No, you have to check it yourself if you want to be sure that you're not making stuff up. So it's pretty fun. It's pretty fun. I mean, you will learn more. You'll kind of enjoy those topics because definitely these graphs are beautiful and very practical. They're used in lots of different sciences. So enjoy your graphing tools and just graph it by yourself in different online graphic tools to check your calculations. See you in my next video.